Hello everyone, I am Mr. Ashish Dattatari Chaudhary, Assistant Professor of Mechanical Engineering Department, VPM's Maharshi Parashuram College of Engineering, Bhubaneswar. Okay, today we are going to start a lecture on air cooling system under the refrigeration and air conditioning course. Now, first we'll see what is the air cooling system. So air cooling system. So many of the times in aircrafts, airplanes, we will require the cooling system, and for that we will use a specific type of cooling system. That type of cooling system are called as air cooling system, because the air is the main uh, fluid which is circulated through the cycle, and due to that we are getting the refrigeration effect. So that's why this system is called as air cooling system. Now first of all we'll see merits and demerits of air refrigeration system. So first of all, merits: the air is easily available and there is no cost of the refrigerant, because we are using a atmospheric air, so that is there is no cost to using the air, to using it is as a refrigerant. Air is non-toxic and non-inflammable, so this is the main advantage. Then next is leakage of air in small amount is tolerable, since the main compressor is employed for the compressed air source, therefore there is no problem of space for extra compressor. So in the refrigeration system will require a compressor, and if you see in the aircrafts, there are the main engine system, there is one of the compressor is used to compress the air, and that compressor is used as a source of the air for the refrigeration system. So that's why we will not require any extra compressor. So this is again advantages for the air cooling system. The air is light in weight per ton of refrigeration. So that's why the what is the devices are used are so much less in weight. Okay. Next, the chilled air is directly used for cooling, thereby limiting the cost of separate evaporator. So because we already see in that second point, the air is non-toxic and inflammable, so we can directly use the air without using the evaporator. Since the pressure in the whole system is quite low, therefore the piping, ducting, etc. quite simple to design, fabricate and maintain. So these are the merits of the air refrigeration system. And I will see demerits. It has low coefficient of performance. Obviously, if you see the air carry energy carrying capacity of air is very much less. That's why it has low coefficient of performance. The rate of air circulation is relatively high, because density of air is very much less, and due to that volume flow rate required will be higher for this air refrigeration system. Now next one, the methods of air refrigeration system. So depend upon several devices and systems, there are these different methods are used for air refrigeration system. So out of that, first one is the simple air cooling system, second is simple air evaporative cooling system, then bootstrap air cooling system, then bootstrap air evaporative cooling system, and then reduced ambient air cooling system, and last one is regenerative air cooling system. Now we'll see one by one. The first one is a simple air cooling system. Okay, so in simple air cooling system we have used the main engine part. So in that engine part, what will happen, the ambient air from the atmosphere will be taken into the engine. So here, due to the ram effect, pressure of the air will be increased, and that air now you are supplied to the main compressor of the engine. So here compression process will be taking place. So out of that, maximum part will be supplied to the combustion chamber and gas turbine. Out of that, some part will be used for the refrigeration system or refrigeration purpose. So that part, now after compression, air is supplied to the heat exchanger. Here we will cool the air by using a ram air. So we have already taken the ram air here, and out of that total ram air, some part we are using for the cooling of this air, because in the compression what will take place, pressure is increased, along with the pressure temperature also increase. So to reduce that temperature will require the some of the medium. So for that we have used the ram air. As compared to main compressed air, ram air is so much cool, or temperature of ram air is, as compared to main compressor air, is less. So that's why we are using the ram air to cooling the compressed air. So here cooling will be takes place into the heat exchanger. After cooling, that air will be supplied to the cooling turbine. So in the cooling turbine, what will happen? Expansion will be taking place, and if you know if expansion will be taking place, that means pressure is going to reduce. If obviously pressure will be reduced, the temperature of that air is going to reduce. Okay. So now after that, after cooling, that air will be supplied to the cabin. So here we will require the refrigeration. Okay. Now here, so ram air after cooling into the heat exchanger. So warm ram air we are supplying over the fan. So due to that, what will happen? Fan will be rotated, and so this is due to the power generated during the expansion of the air. So whatever power generated during the expansion of the air, that power will be supplied to the cooling fan. So that's why the cooling fan take it out or the suck the ram air from the heat exchanger and will supply it to the atmosphere. So this is about the simple air cooling system. Now we'll see the temperature versus entropy diagram of the simple air cooling system. So in that, we will start from the point number one. So point number one is the atmospheric air. So here, if you see here, the ambient air. Okay. So point number one. So 1 to 2 is the ramming process. So this line P1 indicates the pressure of ambient air pressure. Then 2 is the ideal ram pressure. 2 is ideal ram pressure, but due to the efficiency of ram, we will see the actual ram pressure as 2 dash point. So here is the 2 dash point. So 1 to 2 is ideal ramming process, 1 to 2 dash is the actual ramming process. Now after that, if we see ram air we are supplying to the main compressor. So here compression will be takes place. So if you see here, after ramming, that air we are supplying to the compressor. So this is the compression process. So 2 to 3, you will see the main compressor pressure. So here 2 dash to 3 is considered as ideal ram compression process, but in actual practice, due to the efficiency of the compressor, the actual process is different one. So that is indicated at 2 dash to 3 dash at the same pressure. So here we are getting the 2 dash to 3 dash is actual compression process. Now if you see this main compressor air we are supplying through the heat exchanger. So here in the heat exchanger, cooling will be takes place. So here at the same pressure, the cooling will be takes place from 3 dash point to 4 dash point. So at same pressure, temperature of that air, compressed air is going to reduce. Okay. Then now if you see after expansion, that air we are supplying through the cooling turbine. So in the cooling turbine, what will happen? The expansion will be taking place, and we know that in the expansion, what will happen? The pressure will be reduced. So we have 4 to 5 is the ideal expansion process or the turbine process. But due to the efficiency of the turbine, the actual process is different. So that will be done at 4 to 5 dash. So at the same pressure. So this is using the PC is a cabin pressure. So at that the air will be expand. So here we are getting the point number 5 dash. And if you see here, after cooling, the air will be supplied to the cabin where refrigeration will be required. So here if you see 5 dash to 6 is the air is going to supply to at the cabin. So we have seen the 5 dash and 6 points are available at the same cabin pressure. So there is no pressure reduced into this process. So this is about the TS diagram of the simple air cooling system. Now we'll see the processes. So in processes, if you see simple air cooling system, the first process is ramming process. So 1 to 2 is a ramming process, and in the ramming process, we have seen here 1 to 2 is isentropic process. So by using isentropic process, we will see the ratio as P2 by P1 is equal to T2 by T1 raised to gamma upon gamma minus 1. So gamma is the index of the air. So and we know that index of air is 1.4. So by using this one, we can find out the temperature and pressure of the air after ramming process. If you know the P1 and T1, ambient temperature and ambient pressure. Now by using this one, and the efficiency of the ramming process, we will find out the another points. So what is the efficiency of ramming process? Actual rising pressure divided by isentropic rising pressure. So we know that actual rising pressure is P2 dash minus P1 divided by P2 by P1. So put 1 to 2 is the isentropic process. So that's why this is the isentropic one. Okay. Now next one is a compression process. So we already seen the 2 dash to 3 is a isentropic compression process. By using same relation we have used here into the ramming process. By using same relation we can also find out the temperature and pressure of the after compression for the isentropic concept. And similar to using a efficiency of ramming, by using a efficiency formula of compressor we will find out the actual pressure and temperature of the air after the compression. Okay, so in that, so wc will be supplied on the compressor, or you can say the work done on the compressor. This is equal to MACP in bracket T dash 3 minus T2 dash. So here point is 3 dash to 2 dash. This is the actual compression process. So by using this one we will find out the work done on the compressor. So here MA is the mass of air blade from the main compressor for the refrigeration process. That means mass of air circulate through the compressor. Now next one, the cooling process. So cooling process is 3 to 4. If you see here 3 dash to 4 dash is the cooling process. So here you will see the formula. Heat is rejected by the air. So QR is equal to MACP T dash T3 dash minus T4. So cooling process is started from 3 dash point to the 4 dash point. So this is the formula to find out the heat rejected by the air during the cooling process. Now last one, now next one is the expansion process 5 to 4 expansion process. So if you see 5 to 4 is isentropic expansion process. By using isentropic concept we can also find out by using this formula. Similarly we can find out the temperature and pressure after the expansion, and the work done during the expansion we can find out, or work developed during the expansion process we can find out. WR is equal to MACP T4 minus T5 dash. Okay, and last one, the refrigeration process 5 to 6. So here if you see 5 dash to 6, this is the refrigeration process we are supplying to the cabin. So here 5 dash to 6 is the refrigeration process. So RE is denoted by the refrigeration process or refrigerating effect. So this is equal to MACP T6 minus T5 dash. So T6 is outlet of the cabin. So that's why we can use this formula. Refrigerating effect is equal to MACP T6 minus T5 dash. So here T6 is inside temperature of cabin or outside temperature of the cabin. Okay, so by using this one we will find out the calculations to simple air cooling system. Okay, now this one, here you can find out the COP of the simple air cooling system. If Q tons of refrigeration is the cooling load in the cabin, then the air required for the refrigeration purposes. So here mass flow rate is equal to 210 Q divided by CP T6 minus T5. So here 210 is the value of 1 ton of refrigeration in kilojoule per minute. Okay, so this is the value. So that's why, so Q tons multiplied with 210 and divided by the refrigerating effect. So in that we can find out the mass flow rate of air. Okay, now the power required for refrigeration system. So that power we are used in the compression process, actual compression process. So what is which one, that one? So P is equal to MACP T3 dash minus T2 dash. So 2 dash to 3 dash process is a compression process. So whatever compression process energy we require, so MACP T3 minus T2 dash divided by 60. So we will directly get that value of power in terms of kilowatt. And now the COP of the refrigeration system is 210 Q divided by the work supplied to the compressor. So obviously refrigerating effect divided by the compressor work. So this is the COP. So 210 Q divided by MACP T3 dash minus T2 dash. This is equal to in terms of power and the Q tons of refrigeration, 210 Q divided by P into 60. So this is about the COP of simple air cooling system. Now you see the simple air evaporative cooling system. So what is the difference between simple air cooling system and simple air evaporative cooling system? So difference is that if you see here, ambient air is taking place as similar with the simple air cooling system as a ramming process. First is ramming process 1 to 2, then 2 to 3 is main compression process. After that, main compressed air will be cooled into the first heat exchanger by using a ram air similar with the previous method, and after that again this air will be cooled into the evaporator. So what will happen in evaporator? Some of the evaporative medium will be used into the evaporator, during the flight of the aircraft. So what will happen, whatever amount of energy is absorbed by this evaporative medium, what will happen, this medium will be evaporated and doing the cooling of that air into the air evaporative cooling system. So what will happen, again temperature will be reduced at a constant pressure of this air or main representing air. After that, that air will be supplied on the cooling turbine similarly with the simple air cooling system, and again will be supplied to the air cable. Whatever work done during the turbine, that again supplied to the cooling fan, which is dropped the ram air from the first heat exchanger or the heat exchanger, and again supplied to the atmosphere. So this is the main difference is that, so in simple air cooling system and simple air evaporative cooling system, the one of the evaporator is used in the evaporative cooling system. So this is the difference. Now we see in the difference in TS diagram. So 1 to 2 is actual ramming process as it is. 1 to 2 dash 1 to 2 is isentropic ramming process, and 1 to 2 dash is actual ramming process. Then 2 dash to 3 is ideal compression process, and 2 dash to 3 dash is actual compression process as it is. Then 3 dash to 4 dash is cooling system at a constant pressure in the heat exchanger. Okay, and after that 4 to 4 dash is the cooling of air into the evaporator. So this is the 4 to 4 dash at the constant pressure. And after 4 dash there is expansion of air. 4 dash to 5 is isentropic expansion, and 4 dash to 5 dash is actual expansion process, and that air we are supplying to the cabin, and zero point 0.6 is a cabin temperature. Okay, so this is about the simple air evaporative cooling system. Now we'll see the next method is bootstrap air cooling system. So bootstrap air cooling system, so similar to the previous one, again we are using the main engine of the aircraft. So in that ambient air will be taking place, that will be rammed due to the ramming process. Out of that some air will be supplied for the cooling. Then that rammed air will be passed to the main compressor. After compression, that air will be supplied to the first heat exchanger. In the first heat exchanger, the main air will be cooled by using a ram air with same as a simple air cooling system. And after that, the main air of refrigerant process supplied on the secondary compressor. In the secondary compressor, pressure and temperature of that air will be increased, and that will be supplied over the supplied into the second heat exchanger. And in the second heat exchanger, again by using a ram air, that is by cooled, and again it will be supplied on the cooling turbine. So whatever power generated into the cooling turbine, that will be directly supplied to the secondary compressor. So here, and after that, after expansion, the air will be supplied to the cabin. So this is about the bootstrap. So this is about the bootstrap air cooling system. Now we'll see TS diagram. So in TS diagram, 1 to 2 is actual isentropic ramming process. 1 to 2 dash is actual ramming process. So 2 dash to 3 is compression process. Pressure will be increased, temperature also increase, and 2 dash to 3 dash is actual compression process. So now from 3 dash to 4 dash, this is first heat exchanger. In that air will be cooled. After that, compression will be takes place. Second, in the secondary compression, so 4 to 5 dash is isentropic compression, and 4 to 5 dash is actual compression process. Now from 5 dash to 6 is a second heat exchanger. In that main air is cooled, and from 6 to 7 is a expansion of air on the turbine, and 6 to 6 dash is actual expansion of that air, and that air now is supplied to the cabin. So point number 8 is the T8 is the temperature of the cabin. So this is about the simple air evaporative cooling system. Now we'll see the bootstrap air evaporative cooling system. Now the difference between previous one and this one, as the process as it is, we start out from ambient air, it is ramp, rammed air will be supplied on the main compressor. In the main compressor, the compression takes place. Due to that, what will happen? Pressure is increased. Obviously, temperature will be increased. That air will be cooled in first heat exchanger by using a ram air, and that after that, that main refrigerating air will be supplied on the secondary compressor. So in the secondary compressor, pressure and temperature of that air will be increased, and after that, that will be supplied to the secondary heat exchanger. So here what will happen, again cooling will be taking place by using the ram air. Then that air we are supplying to the evaporator. So same with the previous as a simple air evaporative cooling system. Here we have used the extra as a evaporator, in that the medium as used as evaporative medium. What will happen then? Then that medium will be evaporated and cooling will be taking place of the main air. After that, that air will be supplied on the turbine, and due to that expansion will be taking place, and after that, that air by reducing the temperature supplied to the cabin. Whatever power is generated, that will be directly supplied to the secondary. Okay, so now we'll see the TS diagram of the bootstrap air evaporative cooling system. So here again, if we see 1 to 2 is the ideal ramming process, 1 to 2 dash is actual ramming process, 2 dash to 3 is isentropic compression process in main compressor, and 2 dash to 3 dash is actual main compression process. So 3 dash to 4 dash, the cooling of air will be take place in the first heat exchanger. 4 to 5 dash, the air is compressed in secondary compressor. This is a isentropic process. 4 to 5 dash is a actual secondary compression process. 5 dash to 5 double dash is the cooling of air is taking place in second heat exchanger by using ram air. After that, 5 double dash to 6 is the cooling of air by using a evaporative medium into the evaporator. Okay, so that evaporative mediums are alcohol, glycerin, etc. Okay, after that, this cooled air now we have supplied on the turbine. So 6 to 7 is the isentropic expansion process. 6 to 7 dash is actual expansion process. Now after that, after expansion, that air, cooled air, we are supplying to the cabin. So T8 is the temperature of the cabin. So that air at constant pressure we are supplying to the cabin. So this is about the bootstrap air evaporative cooling system. Now next one, we will see this next method is a reduced ambient air cooling system. So reduced ambient air cooling system. So ambient air is taking place into the engine. So here ramming will be taking place. Out of that, some air we are using on the cooling turbine. We will see at later on. So first we'll see main flow of air into the refrigeration process. So ramming air, after ramming, the air will be supplied on main compressor. Compression will be taking place. Pressure and temperature of air will be increased. That air we are supplying through the heat exchanger. So here heat exchanger, main air will be cooled by using a ram air, but this ram air not directly used. It is firstly expand on the first cooling turbine, and what will happen, its pressure and temperature will be reduced, and after that, that air is used for the heat exchanger process. So what will happen, cooled ram air we are supplying through the heat exchanger, and that will be dropped by using a cooling fan with the power generated using the cooling turbine, first cooling turbine. Okay, so this is about the ram airflow. Now about the main airflow, after compression, after reducing the heat into the heat exchanger, that will be cooled or the expand on the secondary cooling turbine. So what will happen, pressure and temperature of air will be reduced, and that air we are supplying to the cabin. Okay, whatever power generated, that is coupled with the reduction gearbox, which is coupled with the first cooling turbine and the cooling fan, and that power addition of this power will be supplied to the cooling fan to suck the air from the heat exchanger, ram air from the heat exchanger. So this is about the reduced ambient air cooling system. Okay, now we'll see. So here you will see the TS diagram of reduced ambient air cooling system. So 1 to 2 is ramming process. So here on the TS diagram, we are only draw the main air flowing through the devices. So main air is used for refrigeration. So 1 to 2 is rammed air. Then 1 to 2 dash is actual ramming. 2 dash to 3 is isentropic compression. 2 dash to 3 dash is main compression process. And if you see the 3 dash to 4, if you see in after compression, that air will be cooled into the heat exchanger. So this is the heat exchanger. Now if you see, so in 3 dash to 4, the cooling of air will be taking place, and after that, that air will be cooled or the expand on the turbine. So if you see here, so that is expand on the secondary cooling turbine, and after expansion, that will be supplied to the cabin. So same is plot here. So 4 to 5 dash is expansion, 4 to 5 dash is actual expansion process, and after that the cooled air will be supplied to the cabin. So this is about the reduced ambient air cooling system TS diagram. Now last process is a regenerative air cooling system. So in that, what will happen, uh, ambient air will be taking place into the engine, ramming will be taking place. The ram air will be supplied on main compressor. Some part of ram air is used into the heat exchanger for the cooling of air. After the main compression, the main air will be supplied to the heat exchanger by using, and here in the heat exchanger it is cooled by ram air, and after cooling that air we are supplying to the secondary heat exchanger. In that air will be cooled and it will be supplied to the cooling turbine. So whatever power will be generated into the cooling turbine, that will be supplied to the cooling fan. This is used to suck the ram air from the first heat exchanger. But here, after the cooling of main air on the cooling turbine, some part of air, after supplying to the air cabin, some part of air will be supplied to the secondary heat exchanger, that is called a regenerative heat exchanger. Because the whatever cooling will be generated by the main air, some part of that air we are using for the cooling of the main air. So that's why this name is given as regenerative heat exchanger. So this is the main part of the regenerative air cooling system. That means the some part of main air will be used for the cooling of same air. So this is about the regenerative air cooling system. Now we see here. Now 1 to 2 is idle ramming process. 1 to 2 dash is actual ramming process. 2 dash to 3 is main compression. 2 dash to 3 dash is actual compression process in main compression. 3 dash to 4 is the cooling in first heat exchanger, and uh, after that the main air will be supplied in second heat exchanger. So that's why a 4 to 5 dash is a secondary heat exchanger, that means a regenerative heat exchanger. So after that we are getting the point number 5 and at a constant pressure. So 5 to 6 is a constant, 5 to 6 is the expansion into the cooling turbine, and 5 to 6 dash is actual expansion. So after that, that air will be supplied to the cabin at the point number 7. So T7 is the temperature of cabin. So this is about the regenerative air cooling system. Now last one, we will see the comparison of various air cooling system based on dry air rated turbine discharge temperature. So if you see, the turbine discharge temperature is taking place from minus 60 degrees Celsius temperature to the positive 6 degrees Celsius temperature. So in that, we have compared based on the dry air rated turbine discharge temperature degree Celsius with the Mach number. So Mach number will be varies from 0.2 to the 2.6. If you see, during the Mach number 0.4 to the 1.6, the simple air cooling system will be used. Okay, so his temperature will be increased. Then if you see the bootstrap air cooling system, So in Bootstrap air cooling system, so here we will see the simple air cooling system gives maximum cooling effect on the ground surface and decreases as the speed of aircraft increases. So here if you see, if speed of aircraft will increase, so simple air cooling system is not the sufficient one. The bootstrap system on the other hand requires the airplane to be in flight so that the ram air can be used for cooling in the heat exchangers. One method of overcoming this drawback of the bootstrap system is to use the part of the work derived from the turbine to drive a fan which pulls air over the secondary heat exchanger, thus combining the features of simple and bootstrap system. As the speed of the aircraft increases, the temperature of ram cooling air rises and the ram air becomes less effective as a coolant in the heat exchanger. In such cases, a suitable evaporant is used with the ram air so that the cabin temperature does not rise. So that means if your temperature will be increased, the speed of the aircraft will increase. So that means in that type, the simple system, bootstrap system, and regenerative system are not useful. In that we have to require the simple evaporative or reduced ambient system or the bootstrap evaporative cooling system, because the ram air is not efficient one. When speed of the aircraft will increase, the temperature of ram air also going to increase, and so if that's why this is insufficient to cool the main air. So that's why along with the ram air we will require some of the evaporative medium to cool that air. So this is about the, if the aircraft speed is going to increase, so in that concept simple evaporative system, reduced ambient system, and bootstrap evaporation system are used. So this is about the comparison of various air cooling system based on DARTD, that means die air rated turbine discharge with the Mach number. Okay, thank you.